Hi everyone, I'm Christopher L. Siguan, UPOU student. I will be discussing about topic 9 and 10.
The transport layer of the Internet TCP and UDP. Transmission Control Protocol or TCP is connection-oriented protocol in which a connection has to be established before both sender and receiver can start communicating. TCP is considered a reliable connection. TCP preforms sequencing of packet to make sure packets are in order. It also utilizes the sliding window algorithm for data transmission. TCP is a more complex protocol compared to UDP or the user datagram protocol. The TCP header is shown on the next slide. The source port and destination port is utilized by the applications to check which service should process the packet received. When the IP packet is received, it will be passed to the correct application on the computer. Sequence number and acknowledgement number field is the field that is being utilized by the TCP sliding window algorithm. Sequence number is also used at the receiver side to check that packets arrived is in the correct sequence. The acknowledgement number is passed to the sender to acknowledge which packet has been successfully received. The control flags on the TCP header provide more control to the application on how the packet can be handled or processed by the application. A connection overview will be shown on the next slide. This connection overview provides a simple illustration or analysis for the flow of the TCP or the transmission control protocol. Host A or host B, or in the real world it can be a server, smartphone, or a computer that is connected to the internet or through the unreliable connection. It is unreliable because there is no guarantee that data will arrive at the destination due to unforeseen circumstances such as a simple loss connection of a network cable, power interruption, and other things. So when the computer sends the data, it will be processed by the receiver through the physical layer and will be passed on upwards to the transport layer, then to the application layer in which the data is displayed or shown to the user. Basically, the OSI model provides an analogy on how a TCP packet flows when it is received by a computer. The next slide will show how a TCP is applied to an application. This slide shows an illustration for TCP Telnet connection. Telnet is an old application which was created and launched in 1969. It is a text-based network protocol for accessing remote computer over a TCP/IP network like the Internet. Telnet is a legacy tool, but it is a very good tool for troubleshooting. From the illustration shown, the port number shown in red box and pink box correspond to a TCP port number. It is noticeable that port 23 on the client PC is also connected to the port 23 of the remote machine. As discussed in the previous slide, that TCP is processed by applications or services running on servers or computers. So if the TCP is sent via port 23, on the other side it should be received also in port 23. If a server sends a data on port 23 and if the data is corrupted and it was received on another port, then the packet will be discarded because the application on the receiving side will not know on how to process the data. You can search the internet on socket programming if you want to delve further about this technology. Next slide shows the list of common applications that use TCP. These are the common application that utilizes TCP. The list assigned to the particular application should not be used for other applications or some unwanted consequences will occur. These ports are restricted ports. The next slide to discuss is about UDP or the User Datagram Protocol. The UDP is opposite to the TCP. TCP requires a connection to be established before transmission begins. Whereas, UDP is considered connectionless, which does not require connection prior to the exchanging of data. UDP is considered unreliable connection because it doesn't bother whether packet is lost during transmission. UDP is commonly used for live video streaming. The receiving end doesn't need to buffer, it will process whatever data it receives from the other end. Consult RFC 768 if you need to dig further on UDP. The next slide is an overview illustration for UDP. The UDP passes through the physical layer from one end to the other. the physical layer doesn't need to be connected physically. The connection can be an irregular network like the Internet. For the packet to get to the other end, source and destination headers are stripped or examined from the physical layer up to the application layer, in which the application layer will show the data to the user. The next slide is about UDP header. The UDP header is not complex as TCP. The source port, destination port should always be there, or else the packet will just be a noise in the transmission if either field is missing. The next slide will show the common UDP ports. You will notice on the table that all of the ports utilize both TCP and UDP. This will make the application quite robust. If TCP cannot be used, then UDP will take its place to process data. Or if UDP is not suitable or cannot be used, then TCP will take place. Usage of either ports will solely depend on how the product or the application was designed. We have been discussing about UDP port, TCP port, and port numbers, but what is a network port? A network port is a process-specific or an application-specific software construct serving as a communication endpoint, which is used by the transport layer protocols of Internet Protocol Suite, such as User Datagram Protocol, UDP, and Transmission Control Protocol, TCP. The next slide discusses about the application layer of the Internet. On this topic we will discuss DNS, URLs, what is www, and email, which is part of our everyday lives. Now let's move on to the next slide to discuss about DNS. What is DNS? Why DNS was invented? Will the Internet be popular today if DNS was not invented? The basic function of DNS is to mask IP addresses into words that human can easily remember. For example, if the IP address of nba.com is 157.166.248.245, it's a 12-digit numbers, whereas nba.com is just 2 words. Words are easy to remember and it makes sense to human rather than those numbers. The only numbers that human can easily remember is when they have money to count. If don't have money to count, that's another story. Let's move on to the next topic about top-level domains of DNS, or the TLDs. The top-level domain, TLD, refers to the last segment of a domain name, or the part that follows immediately after the dot symbol. The Internet Corporation for Assigned Names and Numbers, or pronounced as ICANN, is the entity that coordinates domains and IP addresses for the Internet. The generic top-level domains are shown on the next slide. The TLDs classifies the type of DNS the webpage belongs to. Like the .edu is for educational institutions, the .gov is for government websites, and same thing also for country code. Each country has its own TLD. Now let's move on to the next slide. This slide shows the DNS hierarchy. The next slide will show some detail about this DNS hierarchy. The DNS hierarchy is comprised of the following elements. 1. Root level. 2. Top level domains. 3. Second level domains. 4. Subdomain. 5. Host. It is essential to know about fully qualified domain name, or the FQDN, to understand the DNS hierarchy. A FQDN is the domain name that specifies its exact location in the DNS hierarchy. The next slide discuss about URL. URL is an acronym for Uniform Resource Locator, and is a reference or an address to a resource on the Internet. A URL is assigned to an IP address which is translated by the DNS. Just like in the previous slide, in which www.nba.com, which is a URL, is tied to an IP address. So when the user types nba.com, the browser will be able to know which server should process the request of the user. The next slide show a screenshot about a URL translated to an IP address. This screenshot shows the URL that is tied to an IP address. If the machine or server has been altered or hacked, then if it gets unattended, the user will be a victim of DNS spoofing, in which they will be redirected to a wrong server. Now let's discuss what the www is. www, or the World Wide Web. The web, or World Wide Web, is basically a system of Internet servers that support specially formatted documents. The documents are formatted in a markup language called HTML, hypertext markup language, that supports links to other documents, as well as graphics, audio, and video files. If some websites is not part of www, if the URL is preceded with www, then it will show an empty page. Now let's discuss the amazing email. Email might be an ordinary thing for others since it is almost part of everyone's lives. But email is revolutionary invention that makes the internet popular. Let's discuss the email format on the next slide. The email is composed of the local part and the domain name. The local part is user-defined, but it should be unique within the particular domain name. That's why if you get a Gmail account or any email account, if the local part or the account name has been used, then they will not allow you to create the email account. The domain name part of the email has to be registered through a domain registrar. It must be unique also on the internet. If there are two domain names that exist, then only one of them can be true, the other one can be a spoof DNS name. The next slide shows what composes an email. Email is composed of two, in which the user will type who is the intended recipient. The CC or the carbon copy are the witnesses of the email in the business world. The BCC or the blind carbon copy can be used, but the other people on to or CC loop will not be able to know the email address or addresses on BCC copy. We have come to the end of our discussion. And I would like to say thank you for your time watching this video. Cheers.